All right, 3.6 inverse functions. A couple things you need to know. First thing you need to remember is every relation has an inverse. Okay, in other words, everything has an inverse. Another thing you need to remember is that some relations are functions, all right, and every function has an inverse. And the third item, not every inverse has a function. Is a function. All right. So first thing we're going to look at is we're going to be looking at a graph of an inverse function. Okay. The rule is for every point x, y is on a function, its inverse which would be y comma x. In other words, you switch the x and y. So this new point should be on its inverse yx. Okay, I was going to continue on, but I'm going to stop. For every point x, y is on, a function, its inverse yk. So its inverse would be yk. In other words, you switch the x and y. All right, so how does that look? First of all, let's look at a graph of a function. Okay. So that's, okay, we got 0, 0, we got 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, see, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so here, what's in blue is a function. So we'll call it f of x. All right. How do I know this is a function? First of all, it passes the vertical line test. Okay. All right. And we also should know, you should be able to know what the parent function of this function is. Right. So f of x, it's actually, this equation is x squared. So this is a quadratic function. All right. We'll learn that in section 3.5. All right. Now, by definition, we said that if I take every point x, y, and I flip it, yx, excuse me, having issues here, yx. So if I switch the point, this point should be on the inverse. Okay, so here we have the points. We got, all right, so we have 1, 1, we have 0, 0, negative 1, 1, we got 2, 4, we got negative 2, 4, and we got 3, 9, and negative 3, 9. Right? So all those points are on the function. So if I want these points to be on the inverse, all right, we'll represent in blue, my points would now be this. So 1, 1, switch them is 1, 1. 0, 0, flip it, it's still 0, 0. Switch this, becomes 1, negative 1. This becomes 4, 2. 4, negative 2. 9, 3, and 9, negative 3. So those are my new points. So let me graph those. So we got 0, 0, We got 1, 1. 1, negative 1, so we're going to go 1, negative 1. 4, 2. 2, 3, 4, 2. And we're going to go 4, negative 2. And we're going to go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. And then 9, negative 3. All right, and there we go. We have a new relation. This is the inverse. All right. Now, is this inverse, what's in red, a function? Well, before we get that. So, blue is my function. It's my relationship, or my relation. It's a function, because it passes the vertical line test. If I switch the points, like I did here, in definitions of inverses, I would get this new graph. I get this new relation. Okay. Now this new relation, you notice, is not a function because it fails the vertical line test. So I can't say f of x. All right. I'll just call it something else. Let's call it g of x. All right. That is not a function because it failed the vertical line test. All right. Well, if we look at this, if I go ahead and graph the y equals x line, if you remember this from the first decimals activity on transformation, this is called the identity, that packet that you had to do first, the identity function. All right, it's the y equals x line. So if I would graph that, getting graph straight, folks. There we go. Right. All right, so if you notice here, if I take this paper and I fold it on that identity function, the green line, if I fold it on that green line, you'll notice that this curve will fall right onto this curve. All right, so this takes us to our new definition of what an inverse function is. Right, so let me state it here. F of x and g of x are inverses of each other because they are a reflection of each other over the y equals x line, or in other words, the identity. Sorry, folks, saying all this and you can see it. Identity function. All right, so go ahead and pause the video, finish writing this, and when you're done writing it, continue on. All right, so let me review what we just did here. In terms of graphing an inverse function, well, what you do is, once you have the function, if you reflect it over the y equals x line, you will get the inverse. Okay. If I take some function, reflect it over the y equals x line, you'll get its inverse. That is what inverses are. Okay. Now, if the inverse is a function, then we can write it in function notation. Right? This right here is function notation for inverse. This little prime here, a little dash that looks like a quotation mark, that means inverse. Right? It does not mean 1 over f of x. It's not the reciprocal, not the reciprocal. This means inverse. So if I have some function this, and I have this to it, so that means these two are inverses of each other. That means they are a reflection of each other over the y equals x line.